Okay, this will be my second video to go along with the Unit 3 test, which was all about geometric and algebraic connections. Alright, a section of a rectangle is shaded. The area of the shaded section is 63 square units. So this is 63 units squared. What is the value of x? Well, guess what? The shaded region is a trapezoid. And we know the formula for the area of a trapezoid is like this. It's 1/2 base 1 plus base 2 times height. Alright, that's the formula for the area of a trapezoid. So that should equal 63 since that's the area. So let's just substitute these values into the formula. So we have 1/2. Well, one of the bases is x. The other base is the 7. Alright, these are the two bases, the x and the 7. Alright, and then the height, this is the height, which is another 7. So we have this equation. It only has one unknown, so we should be able to solve it. Okay, I think I will divide both sides by 7 first to get rid of the pink 7 here. So if I divide both sides of this by 7, that will cancel those 7's out. So that's going to leave me with 1/2 x plus 7 is equal to 9. Now, to get rid of the 1/2, I would multiply both sides by 2. Alright, that'll cancel those out. So that's going to leave me with x plus 7 is equal to 18. Then I would subtract 7 from both sides. And that would leave me with x equals 11. Kabam! Let us move on. Okay, what is the area of this parallelogram? Now I know that the formula for the area of a parallelogram is base times height. Unfortunately, because of the way that this parallelogram is oriented, the base, it's difficult to see like what would be the base and what would be the height, and figuring out those lengths would be tedious. So I prefer to use a different strategy called the box method. Gotta love the box method. So by the box method, I will draw a rectangle around this parallelogram, and I will subtract. Okay, so the area of the parallelogram is what I would get if I took the area of the rectangle and I subtracted the 4 triangles around the outside. I didn't even come close to spelling rectangle right. Let me try that again. Rectangle minus the 3 triangles. Okay, I might have to, this might be so embarrassing I have to redo this video. Rectangle minus the 4 triangles. Okay, 1, 2, 3, 4 triangles. So that's my strategy. I'm going to find the area of the rectangle, and I'm going to find the area of the 4 little triangles, and I'm going to subtract. And then that should leave the area of the parallelogram on the inside. Okay, so let's go ahead and do that. Alright, first let's find the area of the rectangle. Well, let's see. I see that over here to the right, I got 6 units, and over here to the left, I have 4 units. So that means I have a total of 10 units going on. And up here I see it's going up to 6. So it's 10 by 6. So the rectangle is 60 square units. Okay, so far so good. Now let's do the triangles. Alright, so triangle number 1. So you know a triangle is 1/2 base times height. Okay, triangle number 1. The base is like right here. Alright, that's 1, 2, 3, 4 squares. The height is right here. That's 1, 2, 3, 4 again. So it's 1/2, 4 times 4. 4 times 4 is 16. Half of 16 is 8. So that's my first triangle. Alright, now triangle number 2. Again, 1/2 base times height. Okay, let me just clean this up a little bit. Don't need these lines anymore. Okay, so triangle number 2. The base of triangle number 2 is right here. That is 6. The height is right here. That is 2. Alright, 6 times 2 is 12. Half of 12 is 6. Okay, now triangle number 3. 1/2 base times height. Alright, for triangle number 3, this is the base, and that is 4, and this is the height, and that is also 4. Alright, so it's the same thing that we had up top. Okay, so again that's going to be 8. And you know what, I'm betting because of symmetry that triangle number 4 is going to be just like triangle number 2. Okay, so yeah, the base 1, 2, 3, 4, 5, 6. The height is 2. Okay, so yeah, so those are the same. So I've got my rectangle and I've got my triangles. Now let's go ahead and figure out the total of all these triangles. Okay, 8 plus 8 plus 6 plus 6. Alright, that is 28. Alright, that means that the parallelogram on the inside here the area of the parallelogram should be 60 minus 28. Alright, so that's going to be 32. Okay, oh, I thought I had some answers down there to choose from. But anyway, yeah, that's it. Should be 32. Okay, how does the area of the triangle compare to the area of the parallelogram? Well, I think we're going to have to find the area of both in order to compare. Alright, I'm going to find the area of the parallelogram first, and because all of these sides are diagonal, you know, nothing's horizontal or vertical, I'm going to use the box method to find the area. Alright, which means I'm going to find the area of the rectangle here, and then I'm going to subtract these 4 triangles in the corners. So here I go with the box method. So first of all, the rectangle, I'm really having trouble with this word. That's just base times height. So the bottom of this thing is 4, and looks like it's a square. It's 4 by 4, so that's 16. So the rectangle is 16. Now I'm going to have 4 triangles. So I'm going to have triangle number 1, triangle number 2, triangle number 3, and triangle number 4. Okay, I'm seeing the symmetry though, so these two triangles are going to actually be the same. So triangle 1, I'll call this triangle 2, triangle 3, and triangle 4. But triangle 1 and triangle 3 are the same shape, same size. Triangle 2 and 4 are the same, so I don't have to do it really 4 separate times. Anyway, so for triangle number 1, it's 1/2 base times height. The base is 3, okay, because it's like 1, 2, 3, and the height is 2. All right, so 1/2 3 times 2. 3 times 2 is 6. Half of 6 is 3. So like I said, triangle 3, that's going to be the same thing. All right, now triangle 2 and 4, the little guys. Okay, looking at triangle 2, the base is 1, and the height is 2, 1 by 2. All right, so this is 1/2 base times height, 1/2 1 times 2. Well, 1 times 2 is 2, and half of 2 is 1. Okay, which means the other one will also be 1. If you add these up, all right, that's 3, 6, 7, 8. Okay, so that means the parallelogram should equal the rectangle minus all the triangles. So 16 minus 8, which equals 8. So that's the area of the parallelogram, is 8. Okay, now let's do the same thing to find the area of the triangle. So first, again, let's find the area of the rectangle. So let's see, the base of this rectangle is 4, and the height is 6. All right, 6 times 4 is 24, so the rectangle is area 24. Now, I'm going to subtract these 3 triangles, and that should leave the area of the big triangle in the middle. Okay, so let's see. I'll call this triangle number 1, triangle number 2, and triangle number 3. So 1/2 base times height. So for triangle number 1, the base is 4. Yep, and the height is also 4. So 4 times 4 is 16. Half of that is 8. Okay, so that was triangle number 1. All right, now look at triangle number 2. The base is 1. The height is 6. All right, 1 times 6 is 6. Half of 6 is 3. Now the last triangle, triangle 3. The base of triangle 3 is 3, and the height is 2. 3 times 2 is 6. Half of 6 is 3. Okay, add all those up. That's 8 plus 6, that's 14. Okay, I didn't mean to write just 14 down like that. What I meant to do was say, so the middle triangle here should be the rectangle area, 24, minus the area of all those 3 triangles. So 24 minus 14. So that is 10. Okay, so the area of this triangle is 10. So how does the area of the triangle compare to the area of the parallelogram? The area of the triangle is 2 more than the parallelogram. All right, the area of triangle ABC is 2 square units greater than the area of the parallelogram. That's what we just said. Kabam. All right, consider a circle whose equation is given. Which statements are true? Check all that apply. Now they're talking about the radius and the center and such. So What we need to do is rewrite the equation of this circle into standard form. Alright, and the way we're going to do that is by completing the square twice. So let's do this. We've got our x terms, which are here and here. We're going to put those together. And then we have our y terms. Well, looks like there's actually only just the one y term, which is fine. That's fine. And then this 8, this negative 8, is going to have to go. So see if you can follow this. Alright, I've got x squared and I've got the negative 2x. Those go together, so I'm going to write those side by side. So I'm going to have x squared minus 2x. Alright, you can see how they go together. Now I'm going to leave a space for a special number here. So then I'm going to move on for the y part. So leaving a gap here, I put plus y squared. Now y squared is great just like it is. Since there is no other y term, like it's not y plus 3x or something like that, then this is really done. Now, the way I move the minus 8 over is by adding 8 to both sides. So I'm going to get this 8 over here like that. Alright, so I won't actually need to complete the square with the y squared because y squared is already a perfect square. Okay, it's already just something squared. It's great, just like it is. Over here, though, I'm going to have to complete the square. The way you complete the square is you look at the middle, you take half of it, and then you square that. So in the middle here I have 2. Half of 2 is 1. Now if I take 1 and I square it, 1 squared, well, this is a special case. 1 squared is still 1. So that's why I'm going to put a 1 in this spot. But anyway, you do half of the middle and then you square it, and that's what you put. Now the biggest mistake is just to do that on one side of the equation. You have to do it on both sides. So if I add 1 to the left, I must add 1 on the right as well. Now the benefit of completing the square is that when you factor it, you're guaranteed to get the same thing twice. So x squared, that's x times x. 1 is 1 times 1. Just a matter of will it be positive or negative. Well, this sign right here is going to tell you that. So since this is negative, then both of these have to be negative. Okay. Now, because both of these are the same, x minus 1 and x minus 1, I can really write this as x minus 1 squared. Alright, now just bringing down the rest of it. So I have plus y squared, and then I have that's equal to 9. Okay, now this is in standard form. You should now be able to tell me the center of the circle and the radius. Okay, let's talk about those things. So the center comes from here and here. Okay, and it's sort of the opposite of what we see here. So this is a negative 1. So for the center, I know I will have a positive 1, comma. Now over here, because it's just y squared and not like y plus 3 or something, then that means that's a 0. Okay, because it's like having y minus 0. So there's my center is 1 comma 0. Now my radius comes from this 9. Remember, in the equation of a circle, this is the radius squared. Alright, so if the radius squared equals 9, that means the radius itself must be 3. So the radius is 3. Alright, because this is 3 squared is 9. Okay, now I can answer the questions. Okay, the radius of the circle is 3. Yep, yes it is. The center of the circle lies on the x-axis. Let's think about that for a minute. Okay, let's do a quick little sketch. The center of the circle is 1, 0. That's over 1, up nothing. So this is the point 1, 0. That's the center of my circle. Is that on the x-axis? It sure is. The center of the circle lies on the y-axis. Nope, it was the x-axis. The standard form of the equation is shown here. Well, yes, we just did that. So the standard form, x minus 1 squared, yep. Y squared, yep. Oh, but then they just have 3. It should be a 9. So that's wrong. So nope. The radius of the circle is the same as the radius of the circle whose equation is shown here. Well, they have a 9 here. And again, that's the radius squared. So, you know, that means the radius is 3. Same thing that happened. They had 9. We had a 9. So the radius would be 3, just like our radius is 3. So that's true. All right, I think that's it. Those 3 are all true. All right, let's reveal and see how we did. Got 'em. Okay, so which statement proves that triangle XYZ is an isosceles right triangle? All right, so if this thing is going to be isosceles, that means that two sides have to be the same length. So we would need to see that XZ was the same length as XY. All right, that would make this isosceles. All right, if XZ was equal to XY. All right, so that's the isosceles part. Now, how about the right triangle part? Right triangle. Well, if it's going to be a right triangle, that means we need a right angle, like 90 degrees. Okay, right there. Now, when you have coordinates and such, you use the slopes. So if we want these to be perpendicular, that's what it would mean. That's what it would take for this to be 90 degrees. Is XZ would have to be perpendicular to XY. Okay, now a way to show whether or not segments and lines are perpendicular, their slopes should be opposite and reciprocal. Okay, so let's look at that. Let's look at their slopes and see if they're opposite and reciprocal. So let's look at XZ first of all. Let's do a rise over run type of a situation. To get from X to Z, I would go up 3 and over 4. All right, that's my rise and my run. So the slope of XZ is 3/4. Okay, now let's compare that to the slope of XY. Now, the fact that it's going downhill from left to right automatically tells me that it's going to be negative. All right, so they are opposite in sign. That part is good. All right, one is going uphill, one is going downhill. That means the first one's positive, the second one is negative. Now let's talk about the rise and the run. Okay, so this is the rise and this is the run. Okay, and this is 4 and this is 3. So it's negative 4 over 3. We knew they were opposites. Are they reciprocal? Yes, 3/4, 4/3. So because they are opposite in sign and reciprocal, we know that these two segments are in fact perpendicular, which shows that they are it's a right triangle. It's a 90-degree angle. So if I need to, I could do the distance formula and calculate these lengths for x, z, and x, y. I'm going to look at the answer choices and see if we can figure it out without doing that. If I need to figure it out, we will. Okay, so which statements will prove that this is an isosceles right triangle? I'm looking for something that says that xz and xy are equal in length, and something about that will show that they are also perpendicular to each other. Okay, which could be the slope thing or what have you. So here it says xz is perpendicular to xy. All right, that's good. That's one of the things I wanted. Xz is perpendicular to xy. Okay, but that only gets me halfway there. That's not enough. Xz is equal to xy, and I see they're saying it's 5. Maybe that's what it turns out to be. But again, that would only get me halfway there. I need a statement that says both. So that's no good. Look at the next one. The slope of xz is 3/4. Yep. Slope of xy is -4/3. Yep. Okay, so that's an indirect way of showing that xz is perpendicular to xy. Okay, so there's one of the two things we needed. And here's the other thing that we needed. Xz is equal to xy. And I see down here that they're saying that it was 5. But there you go. Those are the two statements that I would need. So this one must be the answer. Now, well, wait a minute. Okay, this says 5. Okay, let's see. The slope of this. Okay, this other one is saying something about the slope being 7. That's nonsense. We don't care about that. So it can't be the last one. So it has to be this one. Let's go ahead and reveal and see that we were right. Yepers. Okay, we need to find the perimeter of this rectangle. Well, you know that the perimeter is the length of all the sides added up. So we need to find the length of all the sides. Luckily, we know it's a rectangle, so the opposite sides are equal in length. So really, we only have to do 2 distances. Okay, so let's go ahead and find the length of side EH, for example. Alright, and we will just use the distance formula to do that. So when you do the distance formula, you're doing x minus x and then y minus y. So I'm doing 2 minus 1 squared and then 2 minus -1. Now 2 minus -1 is the same thing as 2 plus 1. Okay, when you subtract a negative, you add. Alright, so I've got that. I'm going to just put that in my calculator. Alright, so we'll just go, we could go square root 2 minus 1 squared plus 2 plus 1 squared. And that is the square root of 10. Okay, so EH here is the square root of 10, which of course means that FG is also the square root of 10. So now let's figure out what about GH? Okay, we'll do the same thing. So we can do -3 minus 2, x minus x, and 4 minus 2. and see what we get. Okay, I got square root of 29. Okay, that means this is the square root of 29, and this is the square root of 29. So the perimeter then, if I start adding these things up, radical 10 plus radical 10, that's 2 radical 10. And then radical 29 plus radical 29, that's 2 radical 29. So some version of this should be the answer. Okay, so let's reveal and see what we had. 2 radical 10 plus 2 radical 29. It's as simple as that. Alright, the perimeter of the rectangle is 28. And they want us to find W. So, well, the perimeter is the sum of all the sides. So if this is 2W minus 1, you know that this is not 3 anything. This is also 2W minus 1. If this side is W, then this is also W. So if I add up all of these, it should equal 28. In other words, why do I keep doing that? In other words, 2W minus 1 plus 2W minus 1 plus W plus W should all add up to 28. Alright, I'm just adding up all 4 sides. But look at your like terms. 2 plus 2 is 4W, 5, 6. So I've got 6W. And then I've got negative 1 and another negative 1 make negative 2. So 6W minus 2 is equal to 28. Adding 2 to both sides, I get 6W equals 30. Dividing both sides by 6. I get W is equal to 5. So that's it for that one. W is 5. Okay, this is going to be the last problem that I am going to do. And we are supposed to find out, alright, what are the x and y coordinates of point P on the directed line segment from A to B, such that P is 2/3 the length of the entire segment from A to B. Alright, this is really the key to the problem right here. It's 2/3 of the way. I'm going to break this up into 2 separate problems. I'm going to do the x separately, and then I'm going to do the y. So first I'm going to do the x. Alright, so if I'm just looking at the x's right now, okay, let me just leave this up here for a second, ready to go. Just looking at the x's, I'm looking at the -6 and I'm looking at the 9. Alright, so what I like to do is I make a number line, okay, involving those 2 numbers. Let me not make it, I don't need to make it quite that big. Okay, so we're going from -6 to 9. Okay, now when you make the number that represents the distance, the total distance from -6 to 9, we want to include the proper sign because the sign reflects the direction. So I'm not just going to, like normally I would just go, alright, this is 15, positive 15. But I'm not going to do that because maybe it's -15, alright, because of the direction. So what you want to do is always do the second number minus the first number. Now when I say the second, I'm talking about the arrow. This arrow goes from the dot to the arrow. The dot is the first. The arrow is the second. It goes from the first to the second, the dot to the arrow. Alright, so when you do your subtraction, you always want to do the second one minus the first one, arrow minus dot. So I'm going to do -6 minus 9. And -6 minus 9 is -15. So that's the way you want to do it. Okay. Now, remember what I said was the key. We want to go 2/3 of the way. So we want to go 2/3 of -15. So I'm going to take my -15 that I just found, and I'm going to do 2/3 of that. Okay. So let's see, what's that? So I'm going to go 2/3 of -15. Okay, that's -10. Okay, now what I do, once I know that I need to go -10 now. So to figure out exactly where that's going to put me, I'm going to take my -10 and I'm going to add it to the first number. So see how my first number is 9? So I'm going to go -10 plus 9. And that's going to give me the final answer here. So -10 plus 9 is going to be -1. So that's my x value. And one more time, just to be clear, this 9 came from the first x value. Okay, now let's do the same thing with the y values. Alright, so my y values are vertical, so I'm going to do them like this. Okay, and so here are my y values, a 7 and a -8. Okay, so here's my 7, which I'll put up high, and my -8, which is low. Okay, so again, I need to calculate the distance between these. And again, I'm not just going to simply say 15, even though I know that's how far apart they are. I'm not just going to say 15, because it could be -15 like it was last time, because that reflects the direction. So again, remember what we do is we do the second number minus the first number. So I have to do the 7 minus the -8. Okay, not the other way around. It's got to be the second minus the first. 7 minus -8. Now 7 minus -8 is the same thing as 7 plus 8. So that is 15. Positive 15 this time. Okay, so that's that distance is a positive 15, including it's a positive direction. By the way, I mean, the reason why the first one was negative is because x value wise it was going to the left. The reason why this one is positive is because looking at the y values, we're going up. Alright, left is negative, up is positive. Anyway, so we have the 15. Still, we're doing 2/3 though, so I need to do 2/3 of this. And in fact, let me give myself a little space, and we'll do 2/3 of positive 15. 2/3 of -15 was -10, so you know this will be positive 10. Okay, now I need to take that positive 10 and add it to the first y value. Okay, and remember the first y value is the -8. So I'm going to take this 10 and I'm going to add the first y value. I'm going to add the -8, so plus -8. And that will give me the actual answer. Okay, so 10 plus -8 is 2. So that equals 2. Alright, so that's the y value. So now I have y is equal to 2. Okay, so that is the x value and the y value. So that's it. As an ordered pair, that's -1, 2. Alright, let's see how we did. -1, 2. And that's how it's done. That brings us to the end of the lesson. I hope this video was helpful to you guys. Good luck on your test.